as we continue our discussion about the analysis model of our software design and the data structures that we need to be able to support our software functionality. So the next set of topics here will be a little bit more discussion about interfaces of our classes, the organization of abstract classes, and also another view at the composition. So these are things that we can speak a little bit more about. So understanding contracts. So basically, contract is an interface, or vice versa. Interface is a contract. So interface is actually a keyword in Java programming language, but in C++ we still use a plain vanilla class to specify the interface. So the interface normally specifies what is to be done, but not how it's to be done. So here's an example of Java interface nameable, something that can be given a name. So it supports getName and setName. So it doesn't have a name, however, it provides specification of two methods that allow us to give a name to a subject of this nameable interface. So here, the same way could be done with a class. So basically, interface is just like abstract class, right? So it's very similar right here. But interfaces should be quickly recognized, and so in the interface, all methods or all operations are automatically public. So in the abstract class definition, we will have to name or give this access specifier as public. In the interface, this is automatic, so we don't use the public specifier normally in the style of writing down the interface. And in UML, we would normally use an italics notation for the interface and normally just use a keyword interface right on top of its name. So this is how both of these would look like in UML as a box. So of course, in programming language, we use these curly braces and the name of the class or an interface. Here we just use the box with three parts. Basically, on top we have the name, in the middle we have the data attributes, and here we have the set of operations. So interface is a contract. Okay, so that's just the core idea of an interface. So here we're trying to use the interface together with other concepts. So this is a UML example, an example of UML diagram that uses both an interface inheritance and also a composition. So essentially, we have a concept of a mammal. Dog is a mammal, and dog has a head, and also dog implements the nameable interface. Okay, so these are all components here. So this is implementing the interface, this is inheriting, and this is a composition or association. So interface is very similar to a class, except that interface has no data attributes. By definition, it has only method declarations, the headers of the methods without declaration. So a few slides back. So the idea of it is that instead of providing what these methods do, we only use semicolon. That's the declaration only, right? So it has no implementation, only declaration. And that's exactly what is expected inside Java interface. So you cannot have Java interface and start providing actual method implementation here. This is only declaration of a method. So class in Java extends from an abstract class that's called a superclass, and similarly we can say that a class in Java implements an interface. Okay, so these are just technically speaking, the relationships and the way we use this in Java. So why do we discuss inheritance, interface, abstract classes, and all of these concepts together? Because in object-oriented programming languages, we have all of these tools which can be used to develop reusable code. Reusable, which is easily adaptable. Reusable does not mean necessarily copy and paste only. You can still do some tweaking, but proper design definitely makes components reusable. So interfaces can only be used with inheritance relationships, and interfaces cannot be used with the composition. Okay, so that's just the theory behind it, but again, we need to use specific examples to kind of like realize that yes, that's really what happens in real software. So Java does not support multiple inheritance of classes, but Java supports multiple implementation of multiple interfaces. So right here in this example, inheritance relationship is a type of relationship. So we say that dog is a mammal, right? So this is how we basically navigate this diagram. In overall, when you're trying to interpret a UML diagram, you cannot go against the arrows. So you cannot say mammal is a dog or anything else, because you only can proceed in the direction of this arrow. So that's why we say dog is a mammal, and is a type of relationship that we provided here. Dog implements nameable. Okay, so that's what we have here, and this is why again we have to start here because of the direction of this arrow. We start right here and we follow the direction of this arrow. So we say dog implements nameable, and that materializes as a pretty useful information for a programmer who wants to start working on these classes and these interfaces. Composition is a has a type of relationship. A composition is kind of, right here, of course, if we wanted to use composition, of course, we would probably have to add a diamond shape right here and fill it with ink like this, right? So this will be the diamond shape like this, and we fill it with ink. So that would indicate composition here. Without this, this is simply an association. So these are the ideas that contract enforcement using interfaces requires that whoever is implementing the interface must provide implementation for all of these methods, all of these operations that were declared as abstract operations here at the interface level have to have concrete implementations at the level of an object or class that implements this interface. So that's the idea right here. So this is enforced directly by the Java programming language, and in C++ it's exactly the same. If you have abstract methods or pure virtual functions in one of the class, and you derive another class, and if you try to build this code and your code does not include the concrete implementation of abstract operations or pure virtual functions, you will get an error from compiler. Compiler will enforce you to provide implementation for all virtual functions, similarly to Java requirement. Multiple inheritance can be very useful in some cases, but Java uses multiple inheritance only in a very limited way with interfaces. So for instance, we can have a system design such that we have a class named person. Okay, so this is class named person, and we have a class named employee. Okay, so we have another class, and these are independent classes. But we want to define class such as teacher. Okay, teacher right here with the T. And we can then make teacher both a person and an employee. So this is an example of multiple inheritance. So this is what we're discussing right here, because interfaces are very limited in their nature. This is sort of a significant limitation in Java with respect to multiple inheritance. And this may lead to sometimes to forcing programmers to repeat the code over and over again because something like this is not available. So we could have found a suitable interface in existing Java software. It already has 10 different functions. So of these 10 functions, we may only need like 3 of them. However, if you're forced to implement all of the functions, then it's for no reason other than Java simply forces you to do that. So the idea is that when you design your own interfaces, you want to keep the interfaces small. And also the possibility is that we can only hope that one day Java will have default method implementation, something that we can reuse in situations like this.